Greetings, math fans. All right, so today we're going to talk about good old vectors. Okay, some of you guys may have seen this already if you've taken physics, or if you're taking physics right now, you may have seen vectors, and so some of this might be a review for you, but that's fine. So let's get started here. First of all, I want to define it. Okay, it's basically an array that represents a magnitude and a direction. Okay, and a magnitude is basically the length of the vector okay, and your direction is which way the arrow is pointing. We'll say arrow. We're really talking about the vector is pointing. Okay, just some really basic things. So let's just start out here. If I have AB, okay, and I'll call this is like a small, lowercase x. And so I can call this vector x, or I can call it vector AB. Okay, notice we use half arrow on top, okay, and the A represents your starting point. We also call this our initial point. And B represents, basically it's our direction. Okay, we call it our ending point. But A starts the vector and B is the direction, because the vector, of course, like I said, it's got a direction. So B is an ending point or terminal point. Okay, so we have a direction and a magnitude. All right, a couple more things here. If I said these two bars represent the magnitude of the vector AB. Okay? All right, so let's talk a few more things here. If I gave you a vector TH, okay, and then I gave you another vector HT, okay, these two vectors are not the same. They basically, just by looking at it, they have the same magnitude. But different direction. Okay? So the deal is two vectors are equal if they have one, the same direction, and two, the same magnitude. Oops. Okay. That's pretty much what it is. All right. A few more things here. Let's talk about a resultant vector. Okay, resultant vector is basically the sum of two or more vectors. And so we're actually going to use, there are two methods to use here, and we're going to actually use both of them. That's why I want to introduce both of them to you. Okay, the first one is called the tip to tail method. So if I give you vector A, and I give you vector B. And if I say what's vector A plus vector B, that's going to, what you do is it's tip to tail. Okay, so I'm going to take, here's my vector A, I'm going to redraw it right here. And basically here's the tip of this vector, and it's going to touch the tail, so the tip here, and it's going to touch the tail of the other vector. So that's the tip of vector A, and it's the tail of vector B. Okay, that's why they call it tip to tail. And then your resultant vector is just that. Okay, it's pretty easy. So this is the deal. Kind of label some stuff here. This is our initial point, and this is our terminal point. Okay, and basically just follow the vector around. Okay, you follow the vector here into here, and that's your that's your resultant vector. That's what we call this guy right here. It's a resultant vector. Okay, and it does, again, it is another vector. So, obviously if I had more than two vectors, you just keep going tip to tail, tip to tail, tip to tail until you find out your get your final answer. All right, it's not too bad. I can actually move these vectors around. Let's look at the other problem now. We're going to use the parallelogram method. So definitely we use the other one, the tip to tail. We're going to use it a lot for bearing problems, okay? Because you're going to go, they say you start at this spot and you go from here to here at this bearing, and then you switch directions, you go from here to here. Well, it's definitely tip to tail, okay? That's actually really, really important. And another, let's say the parallelogram method is kind of the same thing. And here, if I give you guys a vector, let's do that again, vector A and vector B. All right, and basically I'm going to put this as a, well, this is a little bit different than my last example. It's okay. But the parallelogram method is basically putting these guys together. Okay, putting those together, because I can really I can rearrange the vectors any way I want, as long as they're pointing in the same direction and they have the same magnitude. I have not changed the problem at all. All right, so I'm going to put these together like that and like that. And this is what the parallelogram method is. It's creating a parallelogram then. Like that. So this is my resultant vector. And we're actually going to use this quite often too, and the reason we're going to use this is because we're going to be applying law of sines and law of cosines. And what do you guys see right away here? I see a couple triangles. All right, so that's kind of the reason why we're going to use the parallelogram method quite often. All right. Okay, so a couple more things here I can just put on the same page here. Opposite vectors. Opposite vectors are real easy. If that's vector A, then that is vector negative A. Okay, that's all it is. It's an opposite vector is basically the same, has the same magnitude. It just points in the opposite direction. Okay, pretty easy, pretty easy. All right, let's talk about vectors that are equivalent. Okay, remember, math fans, I told you guys in order for a vector to be equivalent, it's got to have the same magnitude, the same direction. All right, so I can't really do this on my screen here, but basically in the classroom, I'm going to go and I'm going to draw a vector like this on the board. And then I'm going to run to the other side of the board, and I'm going to draw another vector over here, just pointing like that. Okay, that's supposed to be kind of similar to that. Okay, and my question is, are these vectors the same? And they are. Okay, so yes, because they're pointing the same direction, and they have the same magnitude, even though it doesn't look like it necessarily. But same direction, same magnitude, those are equivalent vectors. All right, let's talk about scalar multiplication. Okay, it's actually pretty easy. If I said that's vector A, and I want to have vector 2A, you just double the length. That's vector 2A. Okay, and then vector 1/2 A is going to be like this, just half of that vector. Okay, negative 1/2 A, it's going to be the same magnitude, but opposite direction. Okay, and then so let's see. I got vector A. Let's draw vector B. Vector B is going to be let's draw it this way. So let's make it a little bit longer here. Okay, that's vector B. All right, and then I'm going to give you a couple things here. If I said A plus B, especially for a lot of these, the tip to tail is actually pretty easy. Okay, so you're going to take vector A and you're going to draw it like that, tip to tail, and then this guy is vector B, and so it's going to be like that. So this is A and this is B. And then your resultant vector is going to be from the starting point to the ending point. So that is the resultant vector in red. Okay, let's do another one here. How about 3A minus 1/2 B? Okay, well that's, again, it's pretty easy. You're just taking A and you're multiplying it by 3. So it's going to be 1, 2, 3. That's 3A. And then remember, B goes to the left, so now it's going to go to the right, but it's only half the distance. So this is what B looks like. It's half the distance. So this is your A, this is your A, this is your A. It's 3A. And this is negative half of B, going the opposite direction. And then, of course, your final answer looks from the start to there. And that's resultant vector. A little curvy, but you kind of get the point. All right, it's not too bad. Let's talk about vertical and horizontal components. Okay, if I draw a vector A, it's really pretty easy. This right here, of course, is your horizontal component. And this right here is your vertical component. Amazing how they give these things names and they make sense. Okay, horizontal and vertical component. And of course, in order to find these horizontal and vertical components, what we're going to be doing is we're going to be using, it's a little bit of trick, right? Because the nice thing about it is you get a nice little right angle here, and then we can use some right triangle trig to figure out our vertical and horizontal components. Okay, let's do an example here. And this is actually just going to be sketching it. We'll do calculation in a little bit, but if I say given magnitude of vector A is 5, and the magnitude of vector B is 8, and I say theta between the vectors equals 45 degrees. Sketch the resultant. And as I said, we'll get to actually calculating it, the magnitude, a little bit later on. All right, now this is the deal, math fans. I'm telling you theta is, the angle between them is 45 degrees. So I'm definitely going to be using the parallelogram method. And so here's A. And you're like, well, how do you know it's pointing that way? Well, I don't really know it's that way. I just know that the angle between them is 45 degrees. Okay, so, I'm going to kind of sketch it, a little approximate, right? That's 5, and this guy's a little bit longer, so that's 8. And the parallelogram method is just like this. Okay, kind of looks like a parallelogram, all right? And this is, of course, between them. This is 45 degrees. And then here's my resultant vector. Okay, so again, that's kind of why we're using parallelogram now a little bit, because I want you guys to see how how the parallelogram looks and to get that resultant vector. All right. Okay, let's try a couple more examples here. Given the angle of inclination, and that's always from the horizontal, is equal to 40 degrees. And the magnitude of vector v is equal to 100. And I want you guys to find the magnitudes of the horizontal and vertical components. Okay, so, let's sketch it from the horizontal, and it's about 40 degrees. And this vector, here it is, vector v, that's equal to 100. Okay, that's somewhat unitless right now, but that's okay. And it's really easy. I gave you vector v is 100, and I told you the angle of inclination was 40 degrees, and you got to find out the vertical and horizontal components. So that's easy. That's x and y. Of course, what are we going to use? We're going to use sine and cosine. So if I want to find the vertical, I'm going to say sine of 40 degrees is equal to y over r, or y over 100. Okay, and then I cross multiply. I get y equals 100 sine of 40 degrees. So y comes out to be 64.3. And same thing, cosine of 40 degrees equals x over r, x over 100. Cross multiply, x equals 100 cosine 40 degrees. So x comes out to be 76.6. And of course, y being our vertical and x being our horizontal. Okay, it's pretty easy. Okay, let's talk about some forces now that we're actually going to use here. And a unit of force is called a Newton. That's represented by the letter N. Okay, and this came up from Sir Isaac Newton, right? And people always thought that an apple dropped on his head, but and showed gravity. But of course, it wasn't an apple, as we all know. It was really the fig. Okay, he was under a fig tree, and after it hit him, he came up with realized about gravity. He also thought, he kind of tasted the fig, and he's like, this is a really good fig, and he turned it into a cookie cake thing. It was really, really good, and called it the Fig Newton. And he made millions and millions of dollars. Finally, sold his recipe to Nabisco, and that's kind of how you had the Fig Newton. I'm lying about that. Okay, Newton is really just a unit of force. Okay, so a unit of force, and basically what it is, it's you accelerate 1 kilogram mass, or you accelerate a 1 kilogram mass at a rate of 1 meter per second squared. Okay, and so that's acceleration. You're accelerating a 1 kilogram mass at a rate of 1 meter per second squared. People sometimes get confused. They're like, well, I don't understand how acceleration is meter per second squared, because really what it is, it's meter per second. That's velocity, and then how is the velocity changing with time? So meters per second, or meters per second squared. Okay, that's why you have acceleration. Okay, it's pretty reasonable. All right, so let's try a nice little friendly example here. You're given two forces acting on a point in a plane. And the angle between the two forces. So this is kind of just a general, this is what it's going to look like even on your homework and everything. You're going to be given two forces acting on a point in a plane, and you're going to be given the angle between the two forces. Okay? And what you're going to always have to do for me is you're going to find the magnitude of the resulting force, or the resultant force. Okay, so here's your example, math fans. Okay, so you have two forces, 10 Newton force and a 15 Newton force. Okay, so you got 10 doing one and 15 doing another. That's a lot of newtons. That would definitely be a great snack. Angle between them equals 50 degrees. Okay. Well, I can actually move this down here a little bit now. And let's draw our parallelogram. Again, it doesn't really matter. Here's a 10, or it doesn't matter exactly how you draw it, as long as you have an angle between them of 50 degrees. So that's 10 newtons, and I'm going to say the angle between them is 50, so we're going to make it a little bit longer. This is going to be 15 newtons. Okay, and I did, of course, our tails are touching here, which is fine. All right, and then I can draw the parallelogram method, or use the parallelogram method. So let's kind of sketch it out here a little bit. Okay, there's our parallelogram, and this is 50 degrees here. And our resultant vector is going to look like this. Okay, and the deal is I'm trying to figure out the value of that resultant vector. All right, so let's talk. These are some properties of parallelograms. Very important. Very important. Okay, the first property is opposite angles are congruent. Okay, very important. Second property, consecutive angles are supplementary. Of course, we know that's 180 degrees. Okay, and the third one is opposite sides are parallel. Okay, three really important properties of parallelograms. We're going to use them quite often. All right, so here's the deal, math fans. You're given that 10 and that 15 of two sides. What I want you guys to understand is we're going to be using some triangles here. All right, and if this guy right here is 50 degrees, this angle right here is going to be right there supplementary because they're consecutive angles. This is going to be 130 degrees. And if opposite sides are congruent, this is going to be 15 newtons. So the deal is, I really have another triangle here. Okay, I'm going to actually change the color here just so I can show it to you. Okay, I have this guy right here. I have a triangle. And let me sketch that kind of separate here. And this is going to be 10 newtons. This is 15 newtons. And this angle here is 130 degrees. Okay? So this is the deal, math fans. What are we going to use to figure out this guy, our resultant vector? What are we going to use to figure out this guy here? Well, you guys should recognize this. First of all, if I actually label this, this is side angle side. And what do we use for side angle side? Of course, we use law of cosines. We can't use law of sines because we don't have a ratio. Okay, and we can't, with angle side angle, we can figure out the other angle pretty easy, 180 minus those two angles, and get the other angle. But we have to use law of cosines for this, and so let's do that. We're going to say c squared is equal to a squared, which is, we'll say it's 10 squared plus b squared minus 2 times a times b cosine of 130 degrees, the angle included between them, between the two sides. Okay, that's it. So we get c squared is equal to 517.8. Take the square root of both sides, and we get c is equal to 22.8 newtons. And again, math fans, when you're doing these problems, look to see if it makes sense. Because if you type something in wrong in your calculator, you got to understand what it means. Okay? If you have a force that's 10 newtons and 15 newtons, the only way you should realize that it's definitely going to be more than either one of those forces, right? Unless it's, of course, if they're pulling it the opposite direction, maybe it'll be less. Okay, but they're both going in the same, kind of in the same direction, so that's why it's going to be something that's going to be greater than 10 and greater than 15. But it certainly can't be greater than the sum of those, because the only way it can be either or at least equal to it is if you just add them directly together, exact same force in the same direction. Okay, so it's definitely going to be greater than 15. It's going to be less than 25. And so 22.8 newtons, that's a reasonable answer, and that is our answer. All right, so that's pretty much it, math fans. That's just a little introduction of vectors and talking a little bit about some of the properties and a couple of methods we use to solve all the different problems. All right, that's it. Have an outstanding day, math fans. Adios. Goodbye.